Okay, hi, welcome to my next video on the how to predict the structures of the compounds part 2. So here we will see some more examples of other types of compounds and another method of finding out the shape of the compounds with the tips and tricks for those things. Okay, so without wasting time, let's go into the video. So suppose if you take say XeO2F2, XeO2F2 or XeO2F4 like this. So if you take this type of xenon group of compounds, then again we use the same formula, H is equal to half into xenon, valence electron will be 8 plus oxygen is not monovalent, this is divalent. So fluorine is monovalent, so you will have 2 fluorine atom monovalent. Since this is a neutral compound, there is no charge on this, so no cation, no anion. So this will be equal to 5. Hybridization will be equal to 5. 5 means sp3d. Hybridization will be sp3d. Then the number of lone pairs will be hybridization minus surrounding atoms. Hybridization minus surrounding atoms. So hybridization is 5. Surrounding atoms, if you see 2 plus 2, 4. 4 surrounding atoms, which means you have 1 lone pair. You will have 1 lone pair. Now in sp3d, that is this trigonal bipyramidal, the lone pair will occupy the equatorial position. This is an important point you have to remember. In the trigonal bipyramidal structure, the lone pair will occupy the equatorial position. In the octahedral and the pentagonal bipyramidal, the lone pair will occupy the axial position. Okay, that you have to remember. So this will be equatorial position. These two will be axial position. These two will be axial position. So now if you draw the structure of this compound xenon, 3 you will have like this, 4, 5. Now you have O2. I said 1 lone pair will occupy the equatorial position. So this will be the equatorial position. So you will have O, F, F. So oxygen will have 2 lone pairs. Halogen will have 3 lone pairs. So if you are not very familiar with, sir, how do you know which atom contains how many lone pairs? You can watch my another video I have put up in the channel on how to find out the number of valence electrons and the number of lone pairs present in each atom in that video. So please watch that video on how to find the number of valence electrons and the lone pairs on each atom. I have given you another video on that. Okay, so this will be the structure, and remember, lone pair will not contribute to the shape of the molecule. Therefore, the shape of this molecule is not trigonal bipyramidal. If you write it in a different way like this, it will be, you can write it like this: fluorine, fluorine, oxygen, oxygen. So this is something, this will looks like a seesaw shape. Seesaw shape. So the shape of xenon dioxygen difluoride will be seesaw shape, but it is not trigonal bipyramidal, it is not that. So you have to remember, so the lone pair does not contribute to the shape of the molecule, therefore it will change like this. Okay. Now let us see XeO2 and F4. XeO2 and F4. So what will be the this thing here? So you have 4 fluorine atom here. So if you have 4 fluorine atom, you will put 4 here. You will put 4 here because this is monovalent, this is 4. So therefore 8 plus 4, 12. Since this is a neutral compound, no cation, no anion, so this will be equal to 6. So 6 means again octahedral you will have. So octahedral, then the number of lone pairs will be hybridization minus number of surrounding atoms. Hybridization minus number of surrounding atoms. So hybridization is 6. Number of surrounding atom 4 plus 2 is equal to 6. So there is no lone pair. So when there is no lone pair, whatever the predicted shape, it will be the same shape. Only when there is a lone pair, the shape will change. Okay. Now the shape of this compound will be octahedral or square bipyramidal. Square bipyramidal. Okay. Now I will show you another shortcut method. Instead of working out this big problem, suppose if you have, say, ammonia. How to find out the shape of ammonia? So you know that ammonia, nitrogen contains 5 valence electrons. So you write like this: 1, 2, 3, 4, 5. 5 valence electron. You have 3 hydrogen atoms. So H, you put H, you put H. Okay. Now you write S, P, P. Whenever you have free electrons, you make it as a pair. You make it as a pair, you put like this. So now this is sp3. sp3 with 1 lone pair of electrons. sp3 with 1 lone pair of electrons. So sp3 means tetrahedral. Nitrogen will be tetrahedral like this with one lone pair. Lone pair does not contribute to the shape of the molecule, therefore the shape of this molecule will be pyramidal, trigonal pyramidal, trigonal pyramidal. Similarly, if you take an example of water, oxygen is 6 valence electrons. So 1, 2, 3, 4, 5, 6. You have 6 valence electrons. So you put hydrogen, 2 hydrogen is there. Then you have 2 lone pairs. So S, P, P, P. Again you have sp3 as the hybridization with 2 lone pairs. Therefore, the shape of this compound will be oxygen 1, 2, 3, 4. So hydrogen, lone pair. So therefore, here you will have the lone pair repulsion you will have here. Here you will have the lone pair bond pair repulsion here. These two will repel. So here you have lone pair bond pair repulsion. Therefore, this angle will be 104 degree. Therefore, the shape of water molecule will be bent, or you say angular. Bent shape or angular shape. So you can also find out the shape of molecules using this shortcut method, but then this doesn't applies to some of the compounds. For most of the common compounds this applies, for some of the compounds it doesn't apply. Say for example, if you take an ion, say for example CO3 2 minus, then carbon, the number of valence electron is 4. So you will have 4 electrons, you have 3, now you have 2 more electrons here. So you have to put 2 more electrons here, then 3 means O. Now you see there is one unpaired electron here. So sometimes this will be not very easy to use it for some of the compounds. Therefore, for smaller compounds, common compounds like PCl5, SF6, H2O, NH3, XeO2, F2, XeOF4 like this. So we will find out another interesting compound, that is I3 minus. So here the central atom will be iodine, another atom will be this, another atom will be this. So I don't want to do the structure now. Let's find out the hybridization. H is equal to half into fluorine belongs to halogen. The number of valence electron will be 7. So you will have 7 valence electron plus iodine is monovalent. 2 iodine atom will be a peripheral, 1 will be the central atom. So 2, and then cation is 0, anion is 1 you have. So 7 plus 2, 9 plus 1, 10 you will have. So 10 by 2 will be 5. So 5 will be sp3d, which is trigonal pyramidal. Now we have to find out the lone pairs. Lone pair is equal to hybridization minus surrounding atoms. Hybridization is 5. Surrounding atom is only 2 iodine atoms are there. One will be the central atom, another 2 will be the iodine atom. So it will be 3 lone pairs you will have. And as I told you, sp3d this will occupy the equatorial position. Therefore, if you draw like this, 3 lone pairs will occupy the equatorial position, the other 2 iodine will be like this. And the lone pair does not contribute to the shape of the molecule. Therefore, these 3 will go off. The shape of the I3 minus will be linear. Hybridization is sp3d, but the shape is not trigonal bipyramidal, instead it will be linear. So this is what you have to remember in the case of the I3 minus type of ion. Now let us see some more compounds with how do you find out the structures of those compounds. So you will get a question like, now which of the following will have a POP bond, which of them will have PP bond, which of them will going to have POOPP bond. So this can be any atom, like this. It can be phosphorus, it can be sulfur, it can be chlorine, or it can be anything. Okay. Now how do you find out which of the following compounds will have these type of things? So for this you need to know the formulas of those compounds. Say for example, suppose if you take H2SO4. So whatever the acids given from P block, whatever the acids, whether it is sulfur or phosphorus or chlorine or any halogen or any compound, what you have to do is just draw 4 bonds. just draw 4 bonds. Similarly, for say H3PO4, just draw 4 bonds, 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now, see how many O's are there. 4 O is there. So, you put 4 O. 4 O. And remember, in all the acids, H will be attached to oxygen. H will be attached to oxygen like this. H will be attached to oxygen. Now, sulfur contains 6 valence electrons. Now, you have only 4 bonds are here. So, you have to put 2 more bonds to satisfy the 6 valence electrons. So, now this will be the structure of sulfuric acid. Similarly, you have 4 O's here, 1, 2, 3, 4. And as I told you, hydrogen will be attached to the oxygen in this. Now, phosphorus will have, the number of valence electron in phosphorus will be 5. But here there are only 4 bonds. So, you put the 5th bond here. You put the 5th bond here. Okay. So, similarly, now if you want to find out the structure of H3PO3 or H3PO2. So, as I told you, P you put 4 bonds, again you put P 4 bonds. So, here what you do, you have 3 O, H I told you will be attached to hydrogen, but if you put hydrogen here, this bond will be empty. So, you have to put 1 hydrogen here. You have to put 1 hydrogen here, therefore 3 is over, and phosphorus I told you there are 5 valence electrons, so 5th bond will be here. Similarly, here you see there are 2 O's, 1, 2. Hydrogen is 3, but if you put HH here, these 2 will be empty, therefore first you have to put H here, then only you have to put H here. Then only you have to put H here. Now, phosphorus will have 5 bonds, the 5th bond will be put to the oxygen, So, this will be the shape of the H3PO3 and H3PO2. So, this is one easier way of writing the structure of any oxy acids. Okay. So, we will see some more compounds in my next video. Thank you for watching. See the comment section below for online test.